little bit from last week, and we're going to finish up what I didn't get to last week. And so I have a question, and my question is, how many of you in school studied evolution and Darwinian evolution? Who studied that? Okay, so about 80% of us. And so I just want to go back to the grade school lessons and talk a little bit about that. Evolution is not what Darwin called it. Darwin called it descent with modification. His theory is the theory of descent with modification. And descent refers to the descent of generations. So as we go through generations, there are heritable qualities. There are qualities of inheritance, what gets passed on to the next generation, that gets modified over time. Now, this is based largely on what he called natural selection. And natural selection is something that we do observe. And he was an excellent geologist. He was an excellent naturalist. He observed things in nature, and he was a brilliant man. He saw what was going on with natural selection, and he then proposed this theory of descent with modification, and the primary mechanism of that modification, the change in what we would call the genes. He didn't know what a gene was back then. Mendel and his peas, that hadn't been published yet when he was doing this here. So he then took this theory of descent with modification and the observed natural selection, and he applied it to the origin of all species. He took what we could see changing among species and applied it in a much broader sense. Scientists today have taken the same type of approach and said, well, there can be chemical evolution also. And so they have used Darwinian thought to explain first life. We've gone through that in quite a bit of detail in the last couple of weeks. So that is evolution. It is the gradual modification, and that it not only does it explain why we see the same species with a lot of different appearances within the same species. As an example, on the Galapagos Islands, and we had gone kind of through the journeys of Darwin last week, but on the Galapagos Islands, he noticed that these finches were completely different from this island to this island. And he could tell things by their color and their beak sizes and different characteristics of the finches. Same species, but if they're on a different island, they have completely different characteristics that seem to give them survival capability for the unique aspects of that particular island. Whether they had hard nuts or soft nuts, or different kind of predators that maybe the color would give them an advantage in not getting eaten. So that is evolution. It's changes in gene frequency through generations, and then finally applied to a bigger sense in explaining the origins. That's why it was called On the Origin of Species, his book, and I have a copy of it right here. This is actually Darwin's 6th edition of On the Origin of Species. And I have read probably 65 to 70% of it. And there is a common ancestor, and through descent with modification, all of the diversity of life arose on Earth. That was Darwin's claim. That was a radical claim. That was something that was rocked the scientific communities. Hey.
Sorry.
No worries, no worries. Come on in. It rocked the scientific community, and today has become the prevailing view of how all of the species came to be. So how does it work? And we went through this last week, but I just want to go through it so that we've all got the same base as we look at questions about evolution. Number one is the primary mechanism is natural selection, which is genetic variation upon which natural forces act to select a desirable trait, a trait that enhances survival so that the organism can reproduce. It's all about reproducing. It's all about passing on your genetics to the next generation. Those that succeed have an advantage. Those that fail, their progeny won't exist. So the way natural selection works is, say you've got a species of beetles and there's different colors. Some are brown and some are bright green. All the same species, just some variability within that species. We see that all the time. And they're on a particular island that has a lot of brown colors. And so as a bird flying over the beetles, they see the green very easily. Well, they will go down and they will preferentially eat the green beetles because the brown beetles are more camouflaged. So over the course of time, green beetles don't reproduce because they get eaten. Brown beetles reproduce more because they're more camouflaged. So over the course of time, the population of beetles changes from a mixed green and brown to a predominantly brown. That is an example of natural selection. Other mechanisms of changes in genes, and I'm not going to spend a lot of time on this. One of them is genetic drift, and that's just by chance flow of genes. And there's a little example here. You've got there it goes. You've got your population of green and brown beetles. Somebody walks through and accidentally steps on the green beetle. So now, just through no force of preference of brown over green, it just so happens that the green beetles got stepped on. You now have the same outcome. Over the course of time, you've got now predominantly brown as opposed to green. I used the example last week of, say you've got a herd of elk that their habitat is around a volcano. The volcano erupts, it kills everything in their area. Now that particular variation in those elk around that mountain are gone just because of the natural course of a volcano that goes off and kills the wildlife in that area. The next is mutation, and that's random gene changes that can happen. Now the important part of this is an important part of how things change over millions of years, but you have to remember that almost all mutations are bad. When things mutate, we get things that are working perfectly that suddenly don't work anymore. Okay, the consequence of genetic mutation is almost always horrible, bad. And so we have to remember that this as a driving force is usually a bad driving force for survival, not a positive driving force for survival. And the illustration of mutation is just you've got your green beetles as the original beetle species. There's a mutation in the color, and all of a sudden it becomes brown instead of green. And then you start acting with natural selection, where green beetles are preferentially taken out, and you've got to change over time from green beetles to brown beetles. Okay. So this is all how evolution works. And then finally, there's migration, which is just simply the movement of one population to another. It's you've got a population of green beetles and you've got a population of brown beetles, and one day the brown beetle goes into the green beetle, and then they start reproducing together, and then you've got more genetic variation as you go down generations. Okay, so that's all the examples of how it works.
Did you get chartreuse beetles? Sorry, camel beetles.
So when we look at natural selection, what we talked about last week by review is there are certain things that we just simply do not see. In other words, we use natural selection to explain the origin of all of the species from a common ancestor. But in reality, that's not what we observe. We do not observe that. And natural selection cannot explain new life forms as evidenced by, number one, genetic limits.
So all that stuff in the last slide is stuff that we actually do see today.
All of that stuff in the last slide we do see, but the difference is seeing it within species versus using it as an explanation to create completely new life forms.
Right.
Okay, so in scientific terms, we would call one of them microevolution, which is changes within a species. And I think a great example of that is dogs. Okay, I mean everything from the Chihuahua to the Great Dane. Well, they're all dogs. Okay, but this genetic limits, the dogs are a good example because no matter how you breed your dogs, you always have a dog. Okay, you never end up with a new species of something different. Scientists have been reproducing fruit flies, Drosophila fruit flies, for decades, and we have gotten all kinds of mutated fruit flies. We've got fruit flies with 2 wings. We've got fruit flies with 4 wings. We've got fruit flies that'll grow legs where there's supposed to be antennas. You got all kinds of crazy stuff going on with these things, but at the end of the day, they're always a fruit fly. They never create new species. And so we see this process of natural selection working within species, but what we don't observe is speciation, the creation of new species out of this. And there seems to be just some inherent genetic limits. In other words, when you make fruit flies, no matter how much you monkey with their genetics, and no matter how much intelligence goes into trying to change it, you never get anything but a fruit fly, okay? And no matter what dog breeders do, they always get a dog. And there seems to be some built-in genetic limits where you never go beyond the species that you're putting together and trying to manipulate. This is true of corn. You have all kinds of genetically engineered corn, but it's always a corn plant. You have genetically engineered watermelon, and you always get a watermelon from a watermelon seed. There seems to be genetic limits.
But,
Also,
but Darwin's set up his theory to say that if this happened often enough through enough generations, you would end up with different species.
yes.
So it was a pretty outrageous claim, since nobody had ever observed it. And now that they've been trying to make it happen, they still haven't been able to make it happen. So maybe his observations were correct in a limited sense, but he expanded them beyond.
Right. And that's what we're.
Over-
That's why it's titled "Natural
extrapolated.
Selection Can't Explain New Life Forms as Evidenced by." That's
Right.
why.
So,
That's why
so
we
he
titled
took good, true observations and he extrapolated them into unreality. Kind of like if I was to say, well, I was wiser at 30 than I was at 10, and I'm wiser at 50 than I was at 30, and I'll probably be wiser at 80 than I was at 50, and at 120 I'll probably be wiser than I was at 80, and at 190 I'll probably be wiser than, certain good observations only carry so far, and then you hit the limit and you're into fantasy.
And then we talked about changes cyclical, not directional, and we talked about the beaks of finches last week. That what we found was that the beaks of the finch over generations changed in response to the climate. When the climate was dry, they got thicker and harder beaks. That's because in drier climates you had harder nuts to crack. Whereas in wet times you had softer nuts and you didn't need the stronger beaks. And so the changes in the beaks during dry times was towards thicker, harder beaks. But then when there was good wet rain and weather, then the beaks would simply get soft again. So you saw a cyclical change rather than a directional change towards longer, harder beaks. So in other words, they actually would change in one direction and then change back to the other direction. And then when the weather changed, it would change to one direction and back to a different direction. Not in one particular bird, but in their generations during dry climates versus in generations in wet climates. Then we talked quite a bit about irreducible complexity, and that's this concept that there are systems of interacting parts in which the removal of any one part destroys the function of the entire system. An irreducibly complex system then requires each and every component to be in place before it will function. And we talked a little bit about the mousetrap, where you can always get one more step and make it a little bit fancier, and maybe make it a little bit better, and you can get a better and better mousetrap. But if you reduce it down to a basic fundamental element, this mousetrap has got a certain number of parts, and it's got a base, it's got a little staple. Yeah, thanks. Staple. And then it's got a hook, and it's got a spring, and it's got this lever. And it needs every single aspect of that. You can't start with just the baseboard and have it catch a mouse. You can't just have a spring and have it catch a mouse. To catch a mouse, you've got to have every single one of these 5 basic pieces, and they all have to work together. The removal of any one piece makes the whole thing non-functional. And therefore, it would not have any advantage to get little piece-by-piece development. Do you understand what I'm saying? In other words, you can't get a piece-by-piece by gradual change, descent with modification, gradual piece-by-piece change. You have to have all the pieces of this thing engineered together to work in the first place. That is the concept of irreducible complexity. And we see this at the molecular and cellular level. And we talked about, for example, the bacterial flagellum. And we see all the different parts of it. And this thing is, the E. coli is, there's 12,500 of these suckers in 1 inch. It's 1/1000th the width of a human hair. It's a tiny little cell. That there's 240 distinct proteins. Microscopic little outboard motor on its tail, and it runs at 100,000 RPMs. That it takes only a quarter turn at 100,000 RPMs. It takes a quarter turn to stop and turn the other direction. And then this thing here is irreducibly complex. You have to have all the pieces of this outboard motor to have it work. You could not have gradually built this phenomenal little piece of engineering. And so I pointed out that you can look, and it's got a propeller, and it's got bushings, and it's got a rotor, and it's got a stator, and it's got a hook with a universal joint. We recognize all these pieces in our own engineering. And so we look at this and we say, you mean you don't see engineering in this? I mean, really? This is an irreducibly complex system. The pieces don't work by adding a little bit and a little bit and then coming up with an outboard motor. You need the entire system together, a highly engineered system. And so Darwin, in his book, and I've got it flagged here, but he said if it could be demonstrated that any complex organ existed which could not possibly have been formed by successive slight modifications, my theory would absolutely break down. And I think that this is one of the major things that, we do see that. We do see this. We do see this at the molecular cellular level. There's a guy by the name of Michael Behe who wrote a book talking just about these incredibly complicated, irreducibly complex biochemical systems. And so there's lots of these. There's lots of these systems, if you can't get successive slight changes, then the theory does break down. Next is transitional forms would be non-viable, and basically for that we're saying when we talk about one species turning into another species, the transitional forms are not going to have a survival advantage. Molecular isolation, and I'm just going to zip, because I didn't pull my slides up, so I'm just going to zip through these here really quickly. This was the point that if you look at a DNA level, one of the arguments for a common ancestor is the fact that we have a common language in the nucleus of our cell. In other words, whether you're an E. coli or a human being and everything in between, we all have nucleic acid. We have DNA and RNA, and that is the language of the cell. How could it be that the same information that gives us our incredible brain and mind is the same information that allows an E. coli to be alive? And we answered that by saying, well, here we've got two words, two sentences that have 100% of the exact same letters in it, but completely opposite messages. Okay? Charles Darwin is a scientific god. Charles Darwin is a scientific dog. When we see that, 100% of the letters in this are the same. So there's a greater than, the letters are identical, the order is over 90% similar, and the slight change yields opposite, vastly different meanings. This is why I put that up there. So the DNA of a chimpanzee may be 90-95% the exact same as ours. But here we've got 100% of the letters being the same and greater than 90%, but the message is completely different. And the question that we asked last time is it possible that the reason that the E. coli has the same language that codes for how it lives, every protein in its workings, and the DNA of human beings is the same as far as the genetic language? Is it possible because there was a common designer that used the elements in our biosphere, what's here on Earth, to create the language of life? So molecular isolation refers to this here, and it's basically that if you look at a progression like fish to amphibians to reptiles to mammals, okay, there is a progression. If there was descent with modification, if there was gradual change from fish to amphibians to reptiles to mammals, we would expect to find molecules and cellular biology that was in between these things, okay? You would expect to find gradual changes. So we could look at species of fish and amphibians and reptiles and mammals and expect to find that some of them are kind of in between with respect to the molecules of their life. But we don't find that. We find hard stops. We find that fish have a certain system and it is completely different from amphibians. There is molecular isolation between them. There's not a gradual change. We find that there is a hard stop, that the microbiology of amphibians is completely different from that of reptiles. That the molecular biology of reptiles is completely different. We see that they are molecularly isolated, that there's not a gradual change from one to the other. Okay? We just don't observe that slight modification change between these groups of animals. So finally, we were at the fossil record, and this is where we broke off last week. Now, the question is, what do we see in the fossil record? And I want to point out three things that we see in the fossil record. Number one, we see stasis. Stasis means that when we see an organism, that it stays the same in the fossil record. Okay? When we see an organism appear, it appears one way, and then when we see it disappear from the fossil record, okay? In other words, when it becomes extinct, we see it leaving the same way that it came in. We don't see gradual change. We see things leaving exactly the same as they came in. So we see stasis. We see things staying the same. That's just what we see in the fossil record. Okay?
So like a saber-toothed tiger, when they suddenly appear, they've already got those great big teeth.
When the saber-toothed tiger appears, they've got those great big teeth. And when they disappeared, they had those great big teeth.
But you don't see like a tiger with little teeth and bigger and bigger and bigger and bigger and bigger, and then boom, they're giant.
Right.
They're just boom, they're huge.
Right. That's what we see on a saber-toothed tiger. Next, we see sudden appearances. We don't see things gradually appearing in the record. We see a saber-toothed tiger that doesn't have little teeth and then bigger teeth and then bigger teeth and then bigger teeth. What we see is a fully formed saber-toothed tooth. Okay. We see things suddenly appearing in the fossil record. And number 3 is the Cambrian explosion, and I'm going to go into some detail about that because the Cambrian explosion does not fit what one would expect by modification with descent. Okay? Descent with modification. We don't see subsequent slight gradual changes. So let's take a look at the fossil record. What would we expect with macroevolution? Okay? Macroevolution, again, is this theory that the way that all species were created is through evolutionary processes. That one species changes into a different species, like this here. So you've got an organism here, and at some point in time it branches into 2 different organisms, so that this organism is distinctly different from the original, and this one is distinctly different from the original, and this one are distinctly different from each other. You've got a branching tree. Okay? So what would you expect? You would expect gradualism. Gradualism is actually a policy of gradual reform rather than sudden change or revolution. Okay? But in biology, it's the hypothesis that evolution proceeds chiefly by the accumulation of gradual changes. That is Darwin's theory. Okay? And so I just want to remind you that descent with modification is based on gradualisms. Gradual changes that over the long term would result in big changes. But the question is, what do we actually see? What is it that we observe? Well, we observe stasis and the sudden appearance. We observe in the fossil record exactly the opposite of what you would expect if Darwin's theory were true. We see exactly the opposite of what you would expect to see. In that, we see stasis and the sudden appearance of species. Okay? So, stasis. What this means is that when we see T-Rex come onto the scene, it is a fully formed, big, giant tyrant lizard king. And then when we see Tyrannosaurus Rex leave the fossil record in the Cretaceous extinction, he leaves as a fully formed tyrant lizard king. That is stasis. And then sudden appearance. So a couple of weekends ago we went to the museum, State Museum, and if you've been there, it's really interesting. And so I took some pictures here, and this is as you walk into the section where they talk about the origin of the universe and the origin of the Earth. This is on a pole where they've got thousands of little lights that are supposed to represent a little mark of time on the geologic calendar. And at the bottom, it tells you kind of where things fit in. When did we see dinosaurs, and when did we see these organisms and that organisms, and so on and so forth. And I took a picture of it, and it says, life explodes with diversity in the warm, shallow seas that repeatedly sweep across Indiana during the Cambrian period. In the Ordovician period, sea levels continue rising and falling. It is a time of violent storms, cooling climate, and late in the Ordovician, a global ice age and mass extinctions in which hundreds of Earth species vanish. Okay, so I took that picture because it illustrates what I'm trying to make here, which is this is not consistent with gradualism. That even as we sit there and you walk about 20 feet down farther and you will hear and see a video on how life sprang out of our primordial soup, okay? At the same time, it's saying that life explodes with diversity. Life doesn't come by gradual changes into diversity. Life explodes into diversity. A little bit farther down here, just kind of right around the corner, and I wanted to take a picture here. So 700 million years ago, multicellular organisms appear, and it just kind of stays like that for a good long time. And then all of a sudden, multicellular life explodes in Earth's oceans. Organisms from almost every known scientific phylum appear, including trilobites, brachiopods, and corals. So, what I want to point out is that in an instant of geologic time, I calculated this, and it turns out it was 17 minutes. If we take all of geologic time and we were to put it into a 24-hour clock, okay, in the span of 17 minutes, every phylum that exists today just came into existence. So the fossil record shows this. Most information about creatures evolving is shown in the form of evolutionary trees. However, these trees are simply scientists' speculation. The actual fossil record evidence does not show evolutionary trees, but rather evolutionary lawns. Evolutionary trees show one ancestor branching off into other organisms that evolved later in time. In a lawn, however, all the branches are parallel and there's no common ancestor. This means that the creatures existed at the same time rather than evolving into each other. That's why I put this here. See, this is kind of the picture of an evolutionary tree of one creature branching into different creatures, all right? But what we see in the fossil record in the Cambrian explosion is that in a very short period of time, on an evolutionary time scale, on a geologic time scale, you see a few organisms exploding into every known phylum that exists today. This is what the fossil record shows. That's what they mean by an evolutionary lawn instead of an evolutionary tree. You get all of these creatures at the same time coming into existence. So this here, I just have a little scene like this. So this is actually Darwin's. This is from Darwin's notebook. This is his own sketch here in his own little notebooks from when he was formulating and speculating on his theory of descent with modification. But this is what the Cambrian explosion shows, that you've got just a few organisms, and then in a short period of time, you've got every known phylum that exists today.
And still exists today.
Well, that's implied by saying
Right.
exists today. Yeah.
But in other words, they didn't keep on going. Worms were created or became worms, and now they're still worms.
So in the span of a few minutes in geologic time, virtually every known phyla comes into existence. What we don't see is one organism transitioning like branches on a tree, but more like a field of grass suddenly appearing. So finally, natural selection may help explain survival of the species. We observe it happening, but it doesn't explain the arrival of all of our species. Now, one of the main scientific approaches that we've been using would rightfully be called intelligent design. We look at a universe that appears designed for life on Earth. And remember, it seems very finely tuned to allow for life on Earth, that there are so many constants that have to be just so to allow life, that the likelihood that life would occur, there's no chance of life occurring if any of these dozens and dozens of constants are not exactly what they are. The universe is highly organized. It is highly and precisely tuned for life on Earth. So I want to point out the evidence for intelligent design. Number one, we see life that arises only from existing life. We do not observe life arising from non-life. that is just not seen. It is speculated in the far, far past that this is how things came about, but we have not been able to, with all of our collective, intelligently designed experiments, been able to show any type of molecular evolution or approaching life, even with our best intelligence trying to do that. Number two, we see life that consists of millions of volumes of empirically detectable specified complexity. A big mouthful of words. What that simply means is that we look inside of ourselves and we see information. We see design. We see the equivalent of 1,000 volumes of an encyclopedia in one single nucleus of one single simple organism. Okay? We see information. Information implies that there's somebody to put that information there. I mean, we just don't observe information, intelligence coming from non-intelligence. We don't see a message coming from accidental waves and oceans and sands that just kind of come together. Those things never project a message. When we see a message written in the sand, we know that there was an intelligent person that wrote SOS in the sand. Okay? When we see a message, we always know that there was some intelligence behind the message. Well, guess what? We see messages in cells. We see information. Changes occur. We see life that changes cyclically within a limited range. There are genetic limits. Okay, we don't see species turning into other species, and we see changes within that species that occurs cyclically. Okay, not necessarily directionally. We see life that cannot be built or modified gradually. That is the idea of irreducible complexity. We see these systems that must be completely together to allow that system to work and cannot be built by gradual modification. And we see that the different phyla are molecularly distinct from each other. They're their own creatures. They do not have, on a molecular level, they don't have species that are between them molecularly. There's molecular isolation, which suggests that they're just their own distinct entity, rather than the gradual change into a different entity. That fish are distinct from amphibians, okay? That they didn't change gradually into amphibians, that they are distinct from each other molecularly. And the fossil record has fully formed creatures that appear suddenly, they don't change, and then they disappear exactly the same as they appeared. Okay? That doesn't suggest gradualism, that suggests stasis. So, what are some of the objections to ID? And I will tell you, I have been online researching this stuff here, and there is a lot of vehement well, more than pushback. The arguments against it are mostly just slurs and angry, name calling.
Right. Well, because why is this important anyway? I mean, it's important because Darwinists believe that they now have a mechanism in evolution for how the universe and the world and life could have been created without God. That's the whole point of this. You know, it's potentially an atheistic system.
Right, and we're gonna
okay.
and we're gonna address that in just a minute. So here's the objection. Intelligent design commits God of the gaps fallacy. God of the gaps fallacy is this. We see something that we don't understand, so we say God did it. That's God of the gaps fallacy. Well, maybe it's just that we haven't discovered what's going on there. But, you know, how does science proceed if whenever we don't understand something we say, well, God did it? Okay? It's a valid argument. But here's the thing. Intelligent design is not simply the lack of a natural explanation. It's not that we lack an explanation, it's that it's positive, empirically detectable evidence for an intelligent cause. It is recognizing that DNA is a language that codes for information. We are positively identifying a language with information. And it is not a stretch to say that we never see information without somebody imparting that information. We don't see that. We don't see unintelligence creating intelligence. We don't observe that. What we observe is that if we see a Mount Rushmore with the faces of 4 presidents, that somebody chipped the rock to make it look like that. That's what we observe. We don't see nature making the faces of 4 presidents in the Smoky Mountains or the Black Hills. Smoky Hills, the mountains are on the East Coast. Sorry, in the Black Hills. So what we're saying is that we see positive, empirically, meaning you can observe this in nature. Okay, you can test for it and look for it. We have positive evidence for an intelligence cause. It's not that we lack information about something, it's that we see design in there. Secondly, new discoveries are widening the gaps, not making them smaller. In other words, the more we discover, the more we realize that there seems to be more design, that there is more evidence of an intelligent design behind things rather than closing those gaps. In other words, well, if we just knew a little bit more, we would figure out that we don't need God for this. But the more we discover, the more we decide that we need an intelligent cause behind it. The gaps are widening, not closing. Our knowledge gaps get bigger the more we discover, not smaller. Number 3, intelligent design makes the scientific observation that no natural laws cannot produce specified complexity. And that's what we were mentioning just a moment ago. We don't see natural laws and forces making specific things that have information in them. Okay? We don't see the wind and the waves making a face of George Washington in the mountain. Right now they are doing a giant carving in a mountain of Crazy Horse that's been going on for decades. Okay? But there's an intelligent design with an architect and people up there chipping away. We don't see the wind and the rain making Crazy Horse in the mountains. That's what we say. If we see things with information, we can infer that there was an informer of that information. Intelligent design is falsifiable. What that means is that if we see natural laws observed, that if we observe natural laws creating specified complexity, if we observe that, we can say that we've come up with a case where that's not true. Okay? So it's not, God of the gaps fallacy says, well, how can you prove that it's not God? I mean, if you just claim God did it, you can't falsify that. Okay? Either God did or he didn't do it. You can't prove that to not be true. Whereas intelligent design is falsifiable. If we observe natural laws creating specified complexity, creating information, if we see non-intelligence creating intelligent information, then we can prove it to be false. By contrast, macroevolution is not open to falsification. Okay? So, because most macroevolutionists have an a priori philosophical commitment to naturalism. In other words, intelligent causes are ruled out before we look at the evidence. So whenever there's a gap in knowledge, we say, well, if you give it enough time, with enough changes, we can get this. The people that are actually producing the God of the gaps fallacy are the people that apply Darwinian thought to anything that they can't figure out. That's who's applying the God of the gaps. That's not falsifiable. Intelligent design is falsifiable. Okay? Do You guys understand what I'm saying about by falsifiable? In other words, if it's false, you can prove it to be false. Whereas you can't prove macroevolution to be false because they've given a prior commitment to say intelligent causes are ruled out. If there is an intelligent cause, they'll never see it. They'll never find it because it's ruled out before they even look at it. And if they can't figure it out, we'll just apply macroevolutionary thought. We'll just apply Darwinian evolution to it.
Well, and if you talk to a person that does have a commitment that they believe in evolution as the source of all creation, they'll tell you, you know, and you present them with objections, and they'll have very loose rebuttals, such as, oh, well, you know, like we've never seen new species evolve. And they'll say, well, it just hasn't been enough time. Well, how can you argue with that?
Yeah,
You
but
know?
how can you prove it?
That's the problem, right. And
They can't prove it.
right, and what you could say is, well, you ought to see some of it, at least in the fossil record.
Right.
There's been enough time in the fossil record, right? Because you can look back in the history of the Earth for 1 billion years in the fossil record. But what Ken is pointing out is all true. You know, you don't see partial species. You just see one thing, and then you see something else. And you don't see, if there were steps in between, you should see more steps in between than there are the actual things. In other words, if you started with a cat with little teeth, and then you got a saber-toothed tiger, you should find a few cat with little teeth, and a few saber-tooth, and a whole bunch of in between. You know, slightly longer, slightly longer, slightly. You don't see any. But they'll say, well, we just haven't dug up enough in the fossil record. If we keep digging, we'll find them. But like Ken said, the more they keep digging,
Bigger the gaps.
the bigger the gaps, the less they find. They're finding more saber-tooths intact and more animals without teeth, but they've never ever found partially evolved saber-toothed tigers. They keep digging and digging, and they'll just tell you, well, it hasn't been long enough, or we haven't dug up enough. But as Ken says, we haven't seen any. But they'll just fight you and say, well, it just hasn't been long enough time. We haven't dug enough stuff up.
Are they saying that the fossils that they have found they're arguing that they're not the beginning fossils then, right? Is that
They're basically saying, right, if they haven't dug up the in-between species. In
the
other words,
older
Right.
down deeper in the earth than okay.
well, here's the thing, the new thing that they've got now in all the big museums is birds evolved from dinosaurs. They're teaching that as a fact now. It used to be a theory 20 years ago. Now they teach it as a fact. But the fact is, they don't have any animals that are part bird, part dinosaur. Okay, they've got some dinosaurs that look sort of like birds and have bird-like characteristics, but they're dinosaurs. And then they've got some birds that kind of have a little resemblance to dinosaurs, but they're birds. They don't have anything in between. And again, if one evolved into the other, you should see a lot of transitional species. You don't see any. So what they're saying is, well, we just haven't dug one up yet. Well, you shouldn't just dig up one. You ought to be able to dig up a million. Because there should be lots of little gradual changes in between. So you should see a whole bunch of little kind of half bird, half dinosaur. The problem is, if you ever had anything that was a half bird, half dinosaur, it'd be really easy to catch and eat, right? Because it can't quite fly, but it's also not impervious to water. You know, so it's like the transitional forms would be very unstable.
That's it,
They all got eaten.
So-
But if they all got eaten, they should have not have been able to pass those genes on.
That's exactly
and
right.
keep on progressing.
There's no selective advantage for those transitional forms. That's what I mean by the
They're not the fittest.
That's what I mean by the non-viability of transitional forms. They're not more fit, they're less fit. They're less likely to reproduce, not more likely to reproduce. Those are exactly the forms that get eaten and killed and don't reproduce very well.
Right.
Okay.
So it's still really just a theory and not fact.
Oh yeah,
Even though
but they're
claiming it's
teaching it
fact.
like fact. I mean, the kids that are in school, I mean, they teach it like fact. And if you ever go to the Indiana State Museum and look in the basement there, and I mean, they've got the whole thing laid out just as gospel truth, right down to the little video about the primordial stew. It's hilarious. You know, they've got the lightning and oh wow, the first cell, like Frankenstein.
So this is an agnostic, Robert Jastrow. He said this, there's a kind of religion in science that every effect must have its cause. That's true. But there is no first cause. Every effect must have its cause, but we're not going to look at the first cause. Okay? This religious faith of the scientists is violated by the discovery that the world had a beginning under conditions in which the known laws of physics are not valid, and as a product of forces or circumstances we cannot discover. When this happens, the scientist has lost control, and if he really examined the implications, he would be traumatized. That's what we're doing in this class. We are examining the implications of that. Okay? And the implications are, of course, that the only rational conclusion is that there was an intelligence behind it all. That's the only rational conclusion. When that happens, the scientist has lost control. If he really examined the implications, he would be traumatized. As usual, when faced with trauma, the mind reacts by ignoring the implications. In science, this is known as refusing to speculate. So that's what we're asserting here, is that there is a refusal to speculate that there is an intelligence despite the evidence. Okay? And that is why people do not see God in all of the evidence that we're presented.
They've already decided that there isn't a God, that there
So-
can't be a God.
So the conclusion, God or no God, I want to just point out some things that are very basic with this. Okay? I want to point out the faith of the atheist that there is no God. I want to tell you what kind of faith you have to have. Now, what I'm talking about when I say faith is blind belief despite the evidence. Okay? There's gaps in my knowledge, and I'm going to just latch onto this thought anyway. This is the faith of the atheist. Number one, you must believe that something arose from nothing. You've got to believe that
To be an atheist.
to be an atheist. This is the faith of an atheist. You have to believe that something came from nothing out of the origin of the universe. Secondly, that order arose from chaos. That there was a Big Bang explosion, and out of an explosion came a precisely tuned and ordered universe. Okay? Now, we never see order coming from chaos. We only see chaos coming from order. That is the second law of thermodynamics. It's what we looked at about 4 or 5 weeks ago. But you have to totally reject the second law of thermodynamics, which I will tell you, scientists will tell you that is a bedrock. That is a bedrock law. They do not see the laws of thermodynamics being violated. Okay? So you have to throw out the second law of thermodynamics, and you have to believe that order could arise from chaos, that you could have an explosion that leads to a precisely tuned universe for life. Okay? Number three, that you have to believe that life arose from non-life. You have to believe that intelligence arose from non-intelligence. You have to believe that personality arose from non-personality. And that new life arose from existing life forms despite all of the evidence to the contrary that we've been talking about. And that is why I don't have enough faith to be an atheist. Because this requires a leap of faith into the absurd. Throw out common sense to say that naturally something can come from nothing. That intelligence could come from non-intelligence. That personality could come from non-personality. And then we ask the question a little differently, which is, what would the evidence look like if there was an intelligent designer? If creation is true, what would we expect to see? Well, we would expect to see a universe that came to being out of nothing. We would expect that. In the beginning, God created the heavens and the earth. God, spoken word, brought it into existence. We would expect to see exactly what the scientific evidence shows for the beginning of our universe. If creation were true, we would expect a finely tuned universe with life enabling constants within that universe to support life on Earth. We would expect to find a finely tuned universe for life, which is exactly what we see. If creation were true, we would expect that life that is observed to arise from existing life, we would never, we would expect to find life that is observed to arise from existing life, never observed to arise spontaneously. And that's what we find. When we look at the fossil record, we see, when we look at what it would take to get life going, the odds are so against it that it is mathematically impossible. Okay? It's mathematically impossible. It's not what we observe. We have never observed life to arise spontaneously, and we have never even been able to come close to getting the molecules of life created in such a form that it might be possible. If creation were true, we would expect to find millions of volumes of detectable specified complexity. And that is exactly what we find. If creation were true, we would expect to find cyclical changes within a limited range. We would expect that people would be able to, people or organisms, birds, dogs, cats, people, bacteria, that they would be able to change cyclically to adjust and modify with the changes in the environment. If it gets a little wetter, if it gets a little drier, if it gets a little warmer, if it gets a little cooler, that to survive, we need to adapt. Okay? Well, we would expect to see that, and that's exactly what we do see. That we would expect to find specified complexity that cannot be built or modified gradually. We would expect to find irreducibly complex systems. We would expect to find with an intelligent designer systems that are built, already made up to make that organism run, to make life go. Okay? We would expect to find that, and we do. We would expect to find molecular isolation between types, that the different phyla are distinct from one another, and that's exactly what we see. And we would expect to find a fossil record of fully formed creatures that appear suddenly, don't change, and then disappear suddenly. We would expect to see that with creation, and that's exactly what we do see. So the point of this is simply that the scientific evidence is consistent with creation. It is consistent with an intelligent creator. And the difficulty, I think, in the scientific community of seeing that is simply the a priori philosophy that says we cannot find that. That cannot be. We cannot allow God a foot in the door. And therefore, we will cling to what we believe. We will cling to that and use it as an explanation for what we see, despite the fact that this is what we expect in the fossil record, but this is what we see in the fossil record. And that's it for today. Any questions about that?
1 and 3, are they kind of contradictory? The universe was spontaneous, right? It came out of nothing. But then 3 says we don't see anything come out of nothing. I'm confused.
The universe, what science shows is that the universe came out of nothing. That there was nothing and then there was something. And we call that the Big Bang.
But that was
what we
something
observe,
God did.
right? What we observe with life is that life only comes from life. The point is that naturally we do not observe life coming from non-life.
Okay, so that was another. So these are points in which God had to have intervened, because we don't naturally see it. The only explanation for these things is that God exists.
Like the Cambrian explosion. The only reason
Right.
for the Cambrian explosion is that he put them there. There's
Right.
no record that they gradually built to there.
Right, that God built saber-toothed tigers. And when he made a saber-toothed tiger, he made it like a saber-toothed tiger. You know, when he made a T-Rex, he made a T-Rex. And then he killed them off so they wouldn't eat us. That was awfully nice, don't you think? I'm personally happy that they're extinct. Right, so basically, if this is evidence for a creator,
It
which
just
again,
seems like if you put both of those on top of each other, you put that first one you put up about what a scientist believes in, and then you put it on top of this one, they're identical. It's like, what's the scientist even have to argue? Because everything you had on that slide about what a scientist believes in points to the same thing that
Right.
the Christians believe. So,
they just,
That's the point.
yeah, I know.
they
That's
see
the
the
point.
same evidence,
It was just right.
but they close their eyes to the implications.
It was just neat the way you put it in order because it was like exact, the same. I mean, worded different, but essentially the same.
It's like when Ken said about the guy that went to the university and went to the astronomy department looking for the atheists, and they said, oh no, you won't find them here. Come down to the philosophy department.
Right.
Yeah,
Right.
the ones that are actually looking
Right.
and dealing with facts, understand.
I mean, when you study the evidence, you know, people will say, is it possible that God exists? When you look at the evidence, it's impossible that he doesn't exist. Because if he doesn't exist, you have to have a lot of faith to believe that all this stuff happened by itself. I mean, because you don't see that happening by itself, ever. You know, you don't ever throw up a bunch of shards of glass and get a vase. You know, you don't ever take a walk in the woods and see, you know, picture of Teddy Roosevelt carved into a hill. You know, you don't see intelligence coming from non-intelligence. And even the atheists will agree with that, you know, because, you know, Carl Sagan, when he wrote that book and made the movie Contact, the only intelligence that they got all excited about was a string of prime numbers. Like, just a string of prime numbers coming from outer space, you know, in the form of a signal. They knew, wow, that's information. And if there's information coming from outer space, that means, it must mean that there's an intelligent life source out there beaming it to us. So they'll say that about a string of prime numbers. But when you look at the design of flagellums or DNA, they'll say, oh no, that happened by itself. Really? Really? So it's pretty clear that Satan has got the veil. And I'll say, I was a Christian when I went to college, but I was taught this stuff, this evolution, and it was taught to me, and it made sense to me. They didn't explain all that God of the Gap stuff. So they just explained, oh yeah, you know, first we see a fish, and then eventually it changed into an amphibian, and then it changed into a reptile. And I remember one night thinking, you know, this doesn't require God anymore. And if God isn't necessary, then he can't exist. And I lost my faith. I remember the night it happened. And it was after science and philosophy classes in college. Because they basically think they have a way of explaining the universe without God, where God is not necessary.